Hello everyone, welcome to today's Conquer interview algorithm. Today we want to solve problem of number of islands, and we will use BFS algorithm to solve this problem. BFS stands for breadth first search. This is an algorithm used in the graph or tree and some of the circumstances. In the graph, if we want to find all the nodes, there are two possible ways we can search. One way is that we search based on the breadth. For example, if we start from 0 and we can check node 1, 3, 8 that is adjacent to the node 0. Using this way is breadth first search. If it's depth first, it will go into one direction. It will go to 1, 7, 2, 5, 6. So that will be the depth first search. For the breadth first search is usually used to solve these problems. One is graph traversal. It means that you want to get all the nodes of the graph. And also maybe you can get a layered traversal on the graph. The second scenario we can solve is that the node has some dependencies. For example, maybe you want to reach node 1 and you must reach node 0 first. If it has such a dependency, we can use an algorithm called topological sorting to find a possible solution. And the topological sorting is also a kind of BFS algorithm. The third problem we can solve is that shortest path in simple graph. Simple graph means that on the graph, all the paths are identical. There's no different weight on the path. This is a simple graph. And if we want to find the shortest path in such a simple graph, we can use BFS. Otherwise, if it's maybe a complex graph, we cannot use this algorithm. So compared to the BFS, we also have a DFS. We can see the differences. For the BFS, if we search this binary tree, it will go to the A's adjacent node first. It will search on B, then C, and then subnodes of them. If it's DFS, it will go into one way to the leaf. From A, it will search B and then D and then H. Different problems, we can use different algorithms to solve them, and that's the most efficient way. If we want to find all the nodes, we should use BFS. And if we want to find all the paths, we need to use DFS. Okay, you already know the background knowledge, and now let's go to solve the problem. The problem is at lead code 200, and you can search on the lead code and solve by yourself. The problem is given an m multiply n 2D grid map of ones. 1 means land and 0 means water, and return the number of islands. Islands is defined as surrounded by water and is formed by connecting adjacent lines horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. So let's see right side the example. It has a grid and the output should be 3. There are 3 islands in that grid. We check this element if it's in this island, and then we search all the other elements in these islands. Okay, for the BFS, we use a queue. For the queue, we will input as we will input the coordinates, and we can define it as a class, define as a point, and define the constructor. And for the queue, we use point. For all such an issue, we will the BFS is always put the starting node there. And for the BFS, we will check if queue not empty. And then we get that point. Here for the queue, we can also use offer. After get the point, we will do operations there. If that point is just the water, we just ignore. If it's islands, we need to put the adjacent points into the queue. Oh, I think this is char. We should use this one. If it's 0, we just return. Else, we need put for this node, we mark is visited. Here we can simple mark it as water. Then we put all the adjacent elements into the queue. For point x and y, adjacent will be x minus 1, y, x plus 1, y, and x, y minus 1, and x, y plus 1. Okay, I think when all the nodes are being visited, then all the nodes will be 0. Okay. Okay, success. I hope you can understand this BFS structure. For the your code is use the queue and put one element into it, and then is while check if the queue is empty, and then process the queue, get one node from the queue, get one element from the queue, and then process it. That's all for today's topic. Thanks for listening. This is Jenny. See you next time.